and I'll be back. I may not need it, but anyway, so that's where it starts. If I won't be long, whatever. I'll be back. There you go. I should mirror it on the screen first. Goodness gracious. This time of year is always crazy busy, but now with COVID and the fact that we basically have to do so much for grad at the end of this month and not June, this is the part of the year where I go insane. What? Aren't you already insane? Yeah. I don't know because I don't have my textbook, but I will find out for you. I will find out for you. I'm sure you can find it too. Somewhere around page 430. What was that sound? Sorry, I didn't mean to scare you. Oh, success wants in. Did you do this just as I was leaving on purpose? I forgive you. What was that? Oh, that was you.
Ryan, need to read. Right there. Don't read that. You have glasses. I don't know. Ask my eyes how.
So like another 6 months before I can go back and get my new glasses. So I'm saving and not in contacts until.
You're actually gonna get contact?
I forgot my glasses on the way to work like 4 times now.
Nice one.
I'll be driving. I'm like halfway. Cause I didn't realize it until I was driving back. I was driving back. I didn't have my glasses on, and then all of a sudden, oh, my glasses. So I get to a red light, look for them, and I can't find them.
Shoot.
I feel like
And I get home and right there.
I feel like I'll just always wear my glasses. So I can
I look down and just go.
It's unfortunate.
It's also worth mentioning, I feel this is important to say, so I don't sound egotistical or anything. When I say, like I'm a pretty smart guy. Jackson, my son, once said to me, what would you do if you taught somebody who was smarter than you? Like, he was younger when he asked this. I was like, Jack, that's every year. Like, there's people in the room right now that are smarter than me. So I don't want you thinking that I look down on you or anything like that. Taught lots of people that are smarter than me. That diagram's page 433, Mr. TD. My first year teaching, I was teaching, among other things, grade 8 math. And there's this kid, his name is Ryan McDonald. He's an actor in Vancouver now. He was always goofing around and doing whatever. And he's sitting at the back. He's got, like, everybody's in desks. He's at this round table and he's coloring. Because like he needed to have something to do. He was just easily distracted. And I was teaching something. I don't remember what the concept I was teaching. And I'm doing it. And then Ryan kind of looks up, like he's not taking notes or anything. He just kind of looks up. He goes, oh, so it also works like this? And he says something. I'm like, no. And I'm looking at it and I'm trying to change it and I had to write it down, try some things. I'm like, yeah. Like he could see all this stuff. The way some people, when they listen to music, they see colors. Like he's a genius.
Like actually see them? Or just
no, like visualize them,
yeah.
them. Yeah. It's not like he wasn't like playing with things in the air.
I like listen to music all of a sudden it's just green.
Well, but some people do, I think, see. There's a name for it. I can't remember what it's called, but I think they do see colors when they listen to music. Certain music, yeah, like they'll see colors. Yeah, I don't know how it works because
listen to calm music, right?
Yeah.
Kind of blue and purple.
Maybe you're one of them. That sounds so exclusive. Oh, you should sit over there. We're the normal people over here.
The observer is just like a person or someone to take in the sound.
Yeah, exactly. A person or some kind of recording equipment. So my friends at home, or even I guess you guys in the room here, is this thing like on your guys' screen? Does it move around when I do this?
No.
No.
Where is it? Is it on the left
No.
side?
Most movies you can see.
What are you moving?
What am I moving?
Yeah.
The little kind of windows of your guys, like it's a rectangular box that lists Nathan, Kate, Ben, and Success.
Yeah, I don't see that.
So I guess maybe it just comes up in the recording, so it doesn't even.
When you put that on in the recording, like the scene comes up or
Yeah.
whatever, then we see it.
You say when you watch it.
But it doesn't move around or anything.
No, it's just on the right side.
It's always on the right.
Yeah, it's just like the right.
Okay, so then maybe what I should do.
But it would cut off like from sound waves. It would cut off that.
Yeah, so maybe I'll always just move my notes kind of to the left. Maybe that'll hopefully block it, because I know Ada was sending me screenshots yesterday. And yeah, it's just always, like she was saying, it didn't move or anything. Weird. Okay. Anyways, everybody's got this? Kate, can you give me a thumbs up if you haven't already, just so I know I'm sure you have it, but thank you. All right, tons of notes today. And by tons, I mean this is it. Wait, what is this? Yeah. So we want to be really clear. The test is Tuesday. Yep. Test is Tuesday
This is the last lesson.
of this unit. Yep.
Does that say F codes or F OBS?
OBS, observer. And then the FO, that sounds weird saying it out loud. The F naught is technically what it is F sub O. That's what's on the right side here. F naught.
Detector.
Yeah.
Right?
Yeah. V sound plus V detector over V sound plus V source.
Is it a capital?
No, it's speed.
So you said V sound over plus detector over sound and source.
Yeah. Take me down to the river. You know what kind of music I don't like? Country music.
Country music. Yeah.
You know the song I have in my head right now? Country song. My son's like, Dad, listen, just listen. I like it. I admit it. I was reading this interview. Dave Matthews, one of my favorite musicians, and he was asked something about like what his favorite music is, and he said, "If you guys don't know who Miles Davis is a very famous jazz musician, and he was famously asked, you know, what kind of music he likes, and he said, good music. It's not any one particular genre. If it's good, it's good." And that's pretty fair. Can you guys at home hear the video from across the hall, or should I go tell them to turn it up louder?
No, we can't hear that.
Okay, I'll be right back. Yeah, the speed. So like our detector is stationary.
Okay.
So if they're moving,
What's that?
the detector is moving.
Yeah, then it's a much more complicated animal. Yeah. My excuse me, in my SLG this morning, we had a good talk about chapels and stuff, and based on, thank you, Kate, I saw it. You know, just because the Tuesday chapel was so long, We didn't get a chance to talk about it, but it's so interesting to me, you know, thank you, Nathan, where the school, I think there's something like 70 different churches represented or something like that. And it's fascinating to me how just people see it differently, experience it differently. Things that stick out to people, things that some people notice and some people don't. Oh, I need more time in the day. Are we good? Are my people? Thanks, Ben. Are my people in the room? Are everybody good? Are everybody good? That's why I don't teach English. Are everybody good? Okay, so notice this. There's nothing super crazy in this lesson. Notice that when the source is moving towards the detector, it's negative. When moving away, positive. Remember that. You won't be told that. You'll just be given the formula. And I'm one of those guys, I think I told you, like I constantly mix up my east and west. This is something that I would have to memorize if I was writing the test, but I'm not writing the test. I don't have to memorize it, but I keep forgetting it. I keep getting it backwards. So make sure you do commit that to memory. Negative when it's moving towards. Coming at you, it's negative. Are we good to do an example in the textbook? Yes.
East is right.
What do you mean by the source is negative? Like which
source-
value, I guess?
I'm sorry?
Which value would be negative?
The source.
The like FO?
Nope, that's the frequency. It's talking about can you see the mouse on the screen?
Yeah.
That,
Oh, okay.
the speed.
Okay.
Cool.
Yeah.
It would just be you're adding negative.
Yeah. So it's moving towards, it's negative. All right, so let's do an example or dose. What did I say? Oh, that's always there. So let's aim a little left. All right. It's good and focused. That doesn't look good. That's better. All right. Page 435, numero 10. A police car is approaching. So V source equals negative because it's approaching at 20 meters per second, 20. With siren emitting a frequency of 1 kilohertz, so 1,000 hertz. So that's, what is that? What do you guys remember? Is it the observer or the F naught? Which one is it? Sorry? Yeah, it's F naught. Is that what you said? Or were you asking?
It's the F, but he's, what's the F naught?
Oh, yeah, the F naught is the frequency of the object. And then this is what the observer detects, kind of what they hear. And I say they, but I don't know who can listen to something and say, oh, that's 400 hertz. So this will be some kind of machinery.
Is 400, is the hertz like what pitch it is then?
It's more of a loudness. And speed of sound in this case is 330. Now sometimes you will be told, so V sound equals 330. Sometimes you'll be told the temperature is 18 degrees. So you'll have to solve for the speed of sound with like 331.4 plus 0.606 times the temperature. I can't even remember my kids' phone numbers, but I remember that. Okay, so FOBS, that's what we were solving for. I seriously have no idea what their phone number is, or my dad's for that matter. Used to be, I can tell you like my best friend in grade 7, what his 2536184. I can tell you those. But stuff now, everything's just, I just press a button on my phone.
Wait, so is it? Oh, the O and the B are just circles up to dose.
Oh, OBS, yeah.
Yeah.
I'm trying to write as small as I can with a marker.
Yeah.
So it's not like F obs, yeah. Okay, so the speed of sound is 330. Speed of the detector is 0 and will always be. There's no tricks coming with this. It will always be speed of sound being 0. Or sorry, the speed of the detector will be 0. Speed of sound is still 330. Minus 20 times 1,000. So 330 over 310 times 1,000, which I'm sure you can all do in your head, but I need a calculator. 330 times 1,000, 000, divided by 310, 1,064, 1,064.5 hertz. And sig figs, how many are in this question? 2. So it's going to be equals 1,100 hertz or 1.1 kilohertz. Pretty straightforward stuff. Like I said, the trickiest part will be when it says the temperature is -5 Fahrenheit. No, I'm not giving you any Fahrenheit. Is this okay? Are we okay with this? I guess I can keep this down in case there's thumbs ups and downs. Nathan's good. Nathan, you got my email? You're good with that?
Yeah, I think so. I'll look it over again.
Okay. If not, just say so. Next question. Do you need me to do another one, or is this stuff pretty straightforward? And then you can work on math, because I got a couple emails about the amount of math work that I assigned. You want me to do another example?
Yeah.
Okay.
Are you always finding OBS or something?
No, you could do something else. What is this one asking? You detect that the frequency. Yeah, see this one, it's going to be something else. So for question number 2, an ambulance has just passed your home, so it's receding, it's away from you. Okay, so the speed from the source is going to be positive. You detect, so this is F obs. You detect that the frequency of the receding siren is 900 hertz. So F obs is 900. If you know that the frequency of the ambulance's siren is 950, so F naught is 950. Why you would know that, I don't know. Have you noticed sirens sound a bit different now? Like I just noticed the other day, there's something passing and it had this, like it's doing the like wee wee stuff, but there was also this low pulsing. I don't want to make the sound because I won't be able to do it right.
It's like super rapid.
Yeah,
Yeah.
it's low. It's interesting. And I wonder if that's to kind of cut through people's bass if they have their music too high. If you know that the frequency of the siren is 250, how fast is the ambulance moving? So V source is what we're solving for here. The speed of sound in this case is 335. V sound equals 335. So our formula F obs equals V sound plus V detector, so much to write out when really that's just 0, all over V sound plus V source times F naught. F obs is 900. I'm just plugging stuff in now. 900 equals V sound is 335 plus 0 over V sound 335 plus V source, which is, oh, this is what we're looking for. So I'm just going to call that VS. Times F naught is 950. So first thing I'm going to do is I'm going to divide both sides by 950. Get that out of there. 900 divided by 950. 0.947 times 335 over what? Not times. Who's in control? 0.947 equals 335 over 335 plus VS. So now, I don't know why I did brackets, we don't need them here. Easiest thing to do is just switch these two and then divide. So 335 plus VS equals 335 over 0.947, which we'll find out. 0.947. 353.7, 353.7. So now we subtract 335 from this one, so, or from that one. So VS equals 353.7 minus 335 minus 335 is 18.7. Sig figs, 19 meters per second. Give you a couple seconds to make sure that's all written down correctly. Oh, it's a 3 sig fig question. One thing I want you to be aware of is if this was approaching, this would be negative, and that changes things. Okay, but it's receding, so it's positive. Questions?
Is the only 2 units meters per second and hertz?
Yep.
I have a question about something else.
Yeah, not too bad for you. Just kidding. Let me just make sure everybody's good with this. Everybody okay with this? Cool. Everybody's got it written down? Can I get a thumbs up from Kate to know that you're okay? That you're okay. Give me 2 thumbs up in a row if you need me to call 911. All right. Nathan, what up?
I just need an explanation of what a standing wave is.
Okay. Standing wave, good question. Funny, I have a TikTok video. Anyways, a standing wave, let's say, so that's a waveform. And a standing wave, if it's between 2 media, all it will do is it will fluctuate. Like this will always kind of be at equilibrium, and these two will go up and down. So like the reverse of this, if you will. Here we go, markers. Hey, that's not bad. So there's the reverse, but then there's all the kind of in-betweens as this one goes down and this one goes up and so on and so forth. So like it'll also, well, you guys, this might be the best thing I've ever drawn in my life. As a kid, the only thing I would ever draw is Garfield. Let's not talk about that. All right. So it's just a constant fluctuation. You know what? Like maybe let me see if I can find a YouTube video of a slow standing wave and see if that helps at all. Slow motion standing wave. Slow motion in real time. Look at this.
How would someone make a standing
It depends on the right medium, like so for speed on the right wavelength, like it has to be pretty perfect conditions. First of all, Nathan, before I show this, did this, my little diagram, did that make sense at all?
Yeah, I was just like confused about the reflections because wouldn't it just be the red and the blue over and over again, or
Yes.
How does the amplitude fluctuate?
No, you're right. It is the same thing kind of over and over again. So it's like, yeah, as the wave courses through, it just keeps doing this. Like when it hits the end, then yeah, it just keeps going back and forth, back and forth.
Okay.
I'm curious what this video looked like. I haven't seen this before. Well, that looked kind of cool.
That's it.
Yeah, there you go. The rest is advertisements. Too fast. Yeah, it is hard to see it in real time. Slow it down. You know what? With me having oh, that looks cool, hey? With this music, I might not be able to put this lesson on YouTube.
Oh, so they're just using like a motor to put the thing up and down.
See, so this is the fundamental frequency when it's just one anti-node. Okay, I don't need an advertisement here. Does that work for you, Nathan?
Yeah, that makes sense.
All right, now I hope I'm allowed to put this, we'll post this. Who knows? Maybe it's just some local band and nobody will know.
So how would you recreate that in water?
I don't know. I don't know how wave machines work. That's a good question. Thankfully, I invented Google a few years ago, so you can look it up. Any other questions before I end this recording?
Are we gonna learn how to do that?
Nope.
Would that be like an experiment or something to do if we didn't have no time?
Probably not this. What we would do if we had more time is we would do a lot of like final velocity, initial velocity, projectile motion, measuring things like that. You know how much you guys love projectile motion.
Oh, can I do energy transfer like forward?
If you can measure it,
I mean,
yeah.
it has sound waves. It's really loud.
Some of the units,
It's really loud.
some of the units that we had done, there would be like different like kind of projects and presentations instead of a test. And Eric Raffenson, I don't know if you guys remember any of the Raffensons. Was he the youngest? No, Mary was younger. The short version is like they had this rusty piece of metal and submerged it, and then with electricity running through it, got all the rust off of it. So it's pretty neat. Anyways, yes, sir.
Apparently 4 is wrong in the textbook. Someone wrote in my textbook and said that the actual answer is a different
Question number 4.
thing. For the word.
Okay, well, you know what? It seems like this textbooks are never to be trusted. That blew me away the other day with the medium transfer. Half the textbooks are wrong. So do it, and if you feel like it's wrong, then we can cover that next class or the end of this one. Anyways, I'm gonna stop recording before I say something incriminating. What's that?
What was the right answer?
I posted it. You didn't see it on Classroom?
I don't know.
Well, better luck then. All right, I'm ending this. Goodbye, Kate and Nathan.